Welcome, here we go. This is your exam to review video. Remember, I will be available on Friday live at our class time to answer questions, but I try in these videos to be pretty in-depth. So we have been focusing mostly this kind of past few weeks on social science, quantitative methodology, and looking at measurements, statistics, and surveys. So the first chapter, ultimately, we've gone a little out of order, but the first chapter is chapter 4. And this does talk about how we collect data in our research. And as I've mentioned 1,000 times, you're probably sick of hearing me say it, most of the data in quantitative is collected through self-reports or surveys. We do have quantitative data that is also collected through observation and laboratory experiments, but again, much less common than surveys. Now, interviews we consider self-reports as well, and interviews are used in interpretive qualitative data. So that's just kind of the different ways we collect data. Now, whether we're interviewing or surveying, we have to get people. And we consider people, all the people, a population. That's the entire unit or of objects, people, or things that make up the population. And we said today you almost never get a full population because it's just too big. You cannot, look at the problems we're having surveying the entire population in the US. It just doesn't happen. So when we do research, we have to draw a sample from the population, a subset of folks from that population that we're looking for. And that usually, again, helps us to be able to generalize later on. So there are two basic ways that we get samples. We either get a random sample or a non-random sample. What a random sample means that when I go to select a group of people, okay, I'm going to use SDSU students. I want to survey SDSU students. And I say, okay, well, I don't want to survey all of them. That's too many. So what should I do? How do I decide who to include? Well, I can narrow down my population. I can say I just want students from the College of PSFA. That's our college, by the way. So then I've got a more narrow list. Now I can get all the names of the students in PSFA, put them into a hat, or whatever it may be, and start picking out my sample until I have 200 students. Say I want 200. So then I can just start picking them. That would be, if I did that, a simple random sample. I say I want the names of all the students in the College of PSFA. I get all those names, and basically I have to throw all those names in a hat and just draw out my 200 one by one. What that does is it gives everybody in the College of PSFA an equal chance of being included. Now, I could narrow that down even more and say, in the College of PSFA, I only want communication students. So that's a nice number to work with now, because now it'd still be a long list, but I could do it. I could take all the list of all the communication majors and then put all their names in a hat and draw out until I had my 200 for my sample. Okay? That is a simple random sample. Everyone in the population, and a population can be narrowed down, because I could narrow down communication. What if I only want to survey PSFA communication majors who are seniors? Then I might even be able to get that whole population. But if not, I would pick 200 people out of that group at random, and that's how I would get my sample. That is a simple random sample. Now, I messed this up in lecture a little bit, so I want to make sure I can go back and explain. I confused systematic and stratified. So let's talk systematic. Systematic is a little bit different in that instead of putting everyone's names into the hat, I get a list of all the communication majors. say I'm back to all the communication majors. And instead of cutting every single person's name into a strip and putting it into a hat, that's a lot of pieces of paper in a hat, I simply look at my list of names and I say, give me a random number. Shout out a number right now. You shout out 15. I'm like, great. 1, 2, 3, 4, and I go all the way to 15. I pick that person. Then I count 15 more. I pick that person out. And I keep doing that till I have the 200 students I want for my sample. So it is still random, but in a very systematic way. Usually I'm using some kind of number as a basis for choosing. Instead of choosing every single time from the whole population, I'm saying take every 7th person, take every 10th person. So there's a little more of a system to it than just a simple random sample where everyone's in the hat always, okay? Stratified sample, again, is still random, but we're going to break it down into, again, layers or criteria like I just did before. It's not that I want people from PSFA, it's that I want communication majors. I just want communication majors too. I don't even want health communication majors, and I only want seniors. What I've done is I stratified that sample, so then from there, with that stratified sample, I could either do a simple random from that population left or a systematic sample. So you stratify your sample out first into different layers, and then you can pick randomly, either systematically or totally randomly from there. So, okay, I'm not going to try to trick you on these different types. I'm more focusing on the concept of it's random. Everyone has a chance in the population to be picked because we want random samples because it avoids biases. Because we know, just like I was saying, which kind of people comment on Rate My Professor, it's the same thing. Which kind of people will stop and fill out a survey? Well, you know, they may already be predisposed to do that. So if I want to get a survey from comm students, certain ones will do it and certain ones won't. And maybe it's all the ones who like me, and their attitudes may be inherently different about what I'm asking about than the other ones. So I could be missing part of that equation, and I want that. So we like random samples. If they are random, we're usually going to get more diversity in the sample. Unfortunately, a lot of times we have to use non-random samples. This means not everyone in the population gets an equal chance. So I used a convenience network sample for my last research project. I put my survey in SONA. SONA is open to all students in PSFA. However, not all students use SONA. Only if they're going to get extra credit or their professor assigns it do they use SONA. And so are the students who are going to follow through and do the extra credit and use SONA for those classes inherently different than other students in PSFA? I would probably say yes. There are students who don't take extra credit opportunities, and there are students who do. And they have different opinions and different viewpoints. So therefore, I'm only getting the students who want extra credit. And that could make their opinions and their feelings inherently different from other students who don't do extra credit. So it's convenient for me just to put it into SONA, but I know that I'm just going to get students that are taking it for extra credit, that there could be a bias or lack of representation in my sample because I'm doing what's convenient. A network sample we talked about is usually using social media. So where I send out a survey link to my friends, I ask my friends to send it out to their friends, and you can see where this is not random at all. Because, yeah, I have a diversity of friends on my Facebook and Instagram, but yet I don't. I think the majority of them probably share my political views, for instance, and things like that. So again, anytime you're using a non-random sample, your sample has a chance of being more biased, not having as much diversity in it. So network using social media and networking tools. And I mentioned a quota sample where you have to fulfill specific numbers or quotas for certain types of people you want to survey. So I want, we did this a lot at Point Loma. It was fascinating because we did do diversity admissions, which I hated because they were like, well, if we can get 1,000 African Americans, then we've met our quota for what looks good. And I was like, this is so wrong. I hope you're with me on that one. That type of quota sampling, not so good. However, let's go back on the other side and say I'm looking for seniors who have already got a job offer. Communication seniors who already have a job offer. And I ask and put out a call for that. And the first 20 people that answer me, I say, yep, boom, I got my 20, I'm taking them. That's a quota sample. I need 20 who have a job offer, so the first ones who answer me, once I've met my number, I'm done. Okay, hopefully that makes sense. In Chapter 4, you're also introduced to the notion of measurement. We talked a lot about measurement this section. We started with levels of measurement down here, and we also talked about measurement needing to have validity and reliability. So review this very quickly here. Validity says, is the survey or the question measuring the concept it says it's measuring? And I know that sounds weird, but is the question really measuring empathy? And I told you I had a problem once because I wanted to measure neutrality, and the questions I was asking weren't really getting at the concept, so I had a validity issue. I wasn't really measuring the concept. That's validity. Reliability, however, says, can I give this survey again and again and again and get consistent results? You want both validity and reliability. We even use a specific statistic called the Cronbach's alpha to configure the reliability quotient. We say that an instrument is consistent and reliable at a 0.70 or below. So again, you will be being asked to look at these tables and tell me what is the alpha level of certain, of course, articles. So let's look at, and I always forget which article is going to give me what, but we'll do a little scroll here. I've got, actually in this article, and then I will make this bigger for you. This is kind of weird what they've done here. Oopsie, maybe I made it too big. What they've done here is they have put all in one graphic representation. They have put a correlation matrix and all of their descriptive statistics. So let's take a look at what they've done here. Ding. And maybe we'll just narrow that back down just a smidge, right? All right, there it is. So see, what they've done is the first half of this table is actually, these are the variables. Remember, a variable is a concept. We have 11 variables here. This is the mean, the standard deviation, and this is the alpha level. And if I were to look at this, did they measure all of these things reliably? And I would look down the scale and go, hot dang, they have some really high alphas. Remember, 0.7 or above. So, oh, this isn't a marker. I wanted it to be a marker. It won't draw. Never mind. I do these kinds of things and it never works out well for me. Let's undo, close. All right, we'll leave that there right now. So, of course, all of these alpha levels are very high. What is the highest? Again, you would just have to find the highest number in this row. That is 96. And this is the most reliable concept they're measuring, affect for instructor. All right, we'll come back to the correlation, but I just wanted to get through the alpha, the Cronbach's alpha, measure of reliability. We started simple with when we measure things, we do need to know what type of variable it is because it produces different information. So we went through the levels of measurement, and these are on your exam where I give you examples and you'll have to tell me if it's nominal, ordinal, interval, or ratio. So this is really an important part, and I'm going to use very specific wording, and it's going to appear that way on the exam as well. So nominal is a category, and we check mark it. We talked about this as employed, unemployed. Nominal data is mostly demographic data. So you mark your gender or your sex is nominal. You're checking a box. Ordinal, we said, is rank order. So this could be the placement you come in a race. It could be the ordering of freshman, sophomore, junior, senior. Anytime you have to rank order your preferences, I hate having to do that with food. I'm hungry right now, so I'm thinking about food. My favorite number one food, Italian, totally gets the number one. Number two, fish, seafood, but California seafood cuisine, I think. So 2. Yeah, I'm going to rank order my preferences. That's ordinal. Now, interval level. Interval level measures multiple intervals about how you feel about something. So usually this is where we see the Likert scale that says I either strongly agree or strongly disagree. And we talked about this. Interval also can range anywhere up to positive or all the way past 0 into the negative. Okay? That's interval level. It has multiple questions. So it's measuring, again, something like how I feel that online education is beneficial. Strongly agree to strongly disagree. And anytime you're answering a question with multiple intervals between the 1 and the 5, that's interval level measurement. And again, it can be negative, below 0, or above 0. Ratio does the same thing as interval. Ratio still looks at interval level measurement and asks questions based off Likert scales, but instead of going below 0, it has a true 0 or an absolute 0. It does not go below 0. It stops at 0. So that is ratio. Think of examples for all of these. They are on there. I did not have time to talk about types of surveys, so I am going to make sure that that question is not on this exam. All right. Then we got into basic statistics. So once we actually start sending out surveys and we have our random sample or our non-random sample and we have a survey and we have an instrument that is reliable and valid and we know what we're measuring, we can then get some statistical analysis from it. Most statistical analysis is based around the normal distribution or the bell-shaped curve. That's what we're after. And measures of central tendency, please know not just the mean, median, and mode, but that they are called the measures of central tendency. That's a little hint for you for the exam. The mean is the average. The median is the true halfway point. And the mode is the most frequent occurring score. Measures of dispersion look at how numbers fall out. They look at the range. What was the range of scores? And I said we often take exams. People on the exam scored anywhere from a 64 to a 100. What was the range? Now, the variance is basically error and how much you vary from the mean. And standard deviation, remember, is a set way of looking at that variance from the mean. Remember I said right at the beginning here, everything is based on the bell-shaped curve. So we want to look at everything in relation to the mean. Bell-shaped curve. Love the bell-shaped curve. So we'll go to it right here. Just picking up pretty much any picture works. This is a bell-shaped curve right there. Now, what we wanted to do and what happened with standard deviation is it is the variance squared, and we made these areas under the curve and said, here's how we can tell where you are in relation to the mean or the mass. If this is the average and you are 3 standard deviations away, you're pretty different. If you're only 1 standard deviation away, you probably got a similar score or fell in this general area. This is pretty similar. So the further out you go, the more standard deviations away you are on either side. So it's how far you vary from the mean. That's it. All right. I feel like you guys got a lot of this. So now we talked about sometimes we get non-bell-shaped curves. We don't like that. We have to look at what happens when things are skewed. A curve can be skewed positively or it can be skewed negatively. And certainly our last exam was skewed positively. Nobody did poorly. Everything was off to this side high on the bell-shaped curve. Sometimes, though, we also have some other unusual kurtosis or shape, and we talked about leptokurtic. Leptokurtic, I like to say, is where you have a mean or a point in the curve that's too high. I said it leapt right up, and it's way too high. Everybody got a 75, and that's just weird because that doesn't happen by chance, so we might want to go back and look at our data and see what happened. Platykurtic is when a curve plateaus. It really doesn't curve at all. It just remains like a plateau, very flat with a wide range. And that's uncommon too. The interesting thing is central limits theorem. And you do need to know what this is. This says if you want to get a bell-shaped curve, a normal distribution, the bigger your sample, the more it will approximate a normal distribution. If I only survey 2 people and they're at polar ends, I'm going to have a messed up curve. So if I want to approximate or get closer to a normal distribution, guess what I need to do? I need to survey more people. I need to increase my sample size. As I increase the people I survey and increase my sample size, I'll get a more normal bell-shaped curve. Then we talked about inferential statistics, which really the normal curve is back up under central limits theorem. Sorry. Inferential statistics are statistics we can get out of data when we measure things at the interval and ratio level. And some of the advanced things we can do besides for just describe the mean and the median and the mode or the curve, we can talk about and infer relationships. The first one is a t-test. I am not going to test you on those specific terms. Just a t-test compares 2 groups on multiple variables, and it gives you the mean of 2 groups on multiple variables. T for 2 groups, the mean of 2 groups on multiple different variables. I'm wording that very specifically, you guys. The ANOVA, this one, I just want you to know, conceptually, it's going to allow us to look at the variance between and within 3 groups. It's also called the F-test. Oh, not under T. Let's put that under ANOVA, the F-test. Okay. Then we have correlation. It tells us the relationship between 2 variables, and we denote that by the little r. And we often have positive correlations, negative, and curve linear. And we talked at length about these. A positive correlation is when both things are positive, going in the same direction. So the number of years spent in school, the amount of money you make. Negative, one is going up while the other is going down. They're doing the opposite. And remember, we said number of pictures you take of the girlfriend, your happiness level decreases. So 2 things that are in opposition there are a negative correlation. And a curve linear, it starts out increasing and then after time it decreases and ends up in a curve. Let's go back, however, and take a look at the correlation matrix, because that was the one a lot of you said we'd like to review that again. So let's go back and look at this correlation matrix here, because it's a pretty good one. Now remember, I've got my descriptive statistics up front, so I don't want to look at these. I want my correlation matrix. It's really going to start right here. And remember, these numbers across the top refer to the same variables down the side. So you will get a correlation matrix like this on your exam. And I will say to you, what is the highest positive correlation? So this takes a few minutes, even for me. Remember, don't look at these numbers here. Look to this side of it. So we're starting here. I've got a couple, 64, this looks good, 71. So now I'm scanning. I've got another 70, I'm getting all excited. 71, I've got a 77 here. I think that's it right there. Remember, these are alphas over here, so don't include those. This is a 77. So I have got the highest positive correlation here is between number 11, communication satisfaction, and go up, number 8, affect for instructor. So if you like me, you will be satisfied with my communication. There it is. That is a very strong positive correlation. This is an interesting one because there are no negative correlations on here. Remember, if there were, a negative correlation can be strong the closer it is to 1. So let's go with a different question and say, what is the weakest correlation on here? I think I see it, but again, let me cruise through here because these can often be difficult to find. I think it's right here. I think it's 36. Verbal immediacy and clarity is a weak correlation. It's weak. So that would be what you were looking for. I hope that helped a little bit with the correlation matrix part of the exam. I wanted to see if this article did any regressions, which it did not. So we'll choose a different article on our next example. Okay. Save, sure. Sorry about that. Let's get back to the handout we're on. All right, regression analysis. Regression analysis and multiple regression, same, don't worry. That's that R, and again, we can actually make that square by changing it like that. So we're always looking for, wherever this statistic is, what is it pointing to? Multiple regression conceptually says, I have all these variables. I want to know how much of these variables explain this phenomenon. So this is one I use a lot. It's very powerful. It's one of my favorites, obviously. I think you guys know that already. But I will pull up a really quick article and see if we can find a regression here. And that was the same article. Why did I think it was going to be there? Sorry about that. Let me pull this one up because this is one of my papers, so I know it's in here. Boop. Okay, so let's take a look as we're going through here. Here we go. You guys know this table, right? It's descriptive statistics, mean, standard deviation, the alpha level. All right, this is a regression. And this is a stepwise regression. We're looking for R squared. And remember when we were looking at these in class, I said in this type of table, when it lists the actual variables, you want that bottom number. And this is the type of table I am going to give you on the exam. It will have a R squared with the variables listed. And when the variables are listed like this, you want that bottom number. It will also frequently be listed below as the adjusted. Don't want the adjusted, I want the R squared. So if I look to this table, I have all these variables. Here's my R squared column. This is my bottom number. I explained 16% of what contributes to faculty communication about the mission statement. Not that good, guys. Not that good. Very, very modest R squared. So this is actually an F or an ANOVA, and I'm not going to share that or show that with you. Here's a correlation matrix, which you would understand how to read this too. Since this is up here, can you find the strongest negative correlation? Strongest negative correlation. I am looking as well. Again, sometimes these things take time, but I think we've done this one before. I believe it's this -7.3. This is strong, even though it's negative, but it's pulling in the negative. And it was Machiavellian leadership. And number 4, we've done this one before, transformational leadership, which they are exact opposites. Remember, think of a negative correlation. One is going up, one is going down. These two are exact opposites. And they're so opposite, in fact, that we know they're going to go opposite directions. It's a strong negative correlation. All right, regression, R squared, you're looking for that bottom number on this table, because what's happening is as you add in each variable, you're getting the total down here. Same here. Now this one was a much better regression. We explained 50% of what contributes to your provost's communication competence. Certainly it's whether or not they use transformational leadership, do not use Machiavellian, and are religious. 51%. That's what we explained. And apparently table 2 goes there, but those are the tables I want you to be able to read. I also need you to understand what each of these tests do conceptually. All right, that is the study guide. That is the review. You've got textbooks for definitions. You've got all the videos. My recommendation is the same. It is 25 questions. You have 40 minutes. You do not have time to look up every answer in the book. You do not have time to go search online. However, if you do this study guide and make a sheet for yourself that has definitions and has examples, you will do well. You have that access of using the materials. Take the time to write down on the study guide the things I have highlighted, and I guarantee you will do all right on exam 2. I will see you Friday if you have more questions, but for now, that's all I have. Exam 2. We'll take it soon. Bye.